Hello everyone, I am Cadler Navarro and welcome to STS Reporting. For today's presentation, I will going to discuss with you the metallurgy and its content. So let's begin. What is metallurgy? Metallurgy is a domain of material science and engineering the physical and chemical behavior of metallic elements, the intermetallic compounds, and their mixtures, which are called alloys. Metallurgy encompasses both the science and technology of metals, that is, the way in which science is applied to the production of metals and the engineering of metal components used in products for both consumers and manufacturers. Metallurgy is distinct from the craft of metalworking. Metalworking relies on metallurgy in a similar manner to how medicine relies on medical science for technical advancement. A specialist practitioner of metallurgy is known as a metallurgist. Metallurgy comprises of three steps. We have the concentration of ore, isolation of metal from the concentrated ore, and purification of the metal. The first steps of metallurgy is called concentration of ore. That is the process of removal of unwanted material from the ore. Is known as concentration or dressing, or what we call benefaction of ores. The second one is called isolation of metal from the concentrated ore. It involves the refining of metals from the compounds it is found with to its original state. The third one is called purification of the metal. Refining consists of purifying an impure metal. It is to be distinguished from the other processes such as smelting and calcining, and that those two involve a chemical change to the raw material, whereas in refining, the final material is usually identical chemically to the original one, only it is purer. In metallurgy, there are two elements. We have the chemical metallurgy and physical metallurgy. So let's find out what chemical and physical metallurgy is. Chemical metallurgy is chiefly concerned with the reduction and oxidation of metals. Subjects of study in chemical metallurgy include mineral processing, the extraction of metals, thermodynamics, electrochemistry, and chemical degradation, or what we call corrosion. So these are the examples of chemical metallurgy. The second element of metallurgy is called physical metallurgy. It is focuses on the mechanical properties of metals, the physical properties of metals, and the physical performance of metals. Topics studied in physical metallurgy include crystallography, material characterization, mechanical metallurgy, phase transformations, and failure mechanism. So these are the examples of physical metallurgy. Historically, metallurgy has predominantly focused on the production of metals. Metal production begins with the processing of ores to extract the metal and includes the mixture of metals to make alloys. Metal alloys are often blend of at least two different metallic elements. However, non-metallic elements are often added to alloys in order to achieve properties suitable for an application. The study of metal production is subdivided into ferrous metallurgy, also known as black metallurgy, and non-ferrous metallurgy, also known as colored metallurgy. Ferrous metallurgy involves processes and alloys based on iron, while non-ferrous metallurgy involves processes and alloys based on other metals. The production of ferrous metals accounts for 95% of world metal production. Modern metallurgists work in both emerging and traditional areas as part of an interdisciplinary team alongside material scientists and other engineers. Some traditional areas include mineral processing, metal production, heat treatment, failure analysis, and the joining of metals, that is including welding, brazing, and soldering. In summary, Emerging areas for metallurgists include nanotechnology, superconductors, or composites, biomedical materials, electronic materials, or what we call semiconductors, and lastly, surface engineering. So this is my presentation, and I hope you've learned a lot from this. Thanks for watching.